Greetings, fellow nerds, and welcome to another episode of Between Two Nerds, our first episode of 2023. And I'm Jeff Doyle, and with me, I should mention, Jeff Tansura is off for the week, and so standing in as a guest host is our friend and colleague, Robert Lancaster. And if you've been following this show for any length of time, you've probably been following Robert more than you know you have. Robert is our producer for the show and is always in the background pulling the levers and turning the valves and everything to make it work so that Jeff Tansura and I can just get on the show and start talking. But Robert is an exemplary presenter himself. And so while Jeff is off, I thought it would be great to have Robert in front of the camera for a change. So anyway, welcome, Robert.
Thank you, Jeff. So nice to be on this side of the camera.
Yeah.
I wanted to add one thing to what you said there. There's handling both nerds takes two people. And there's another gentleman behind the scenes today named Sean Christensen, who's doing my usual job, and Sean is another critical pillar in the Between Two Nerds streamcast. So mention that.
Absolutely,
but
yeah.
It's great to be here. It's great.
All right.
I know you wanted to talk about Apstra and some new capabilities. Should I mention who else is lurking on the screen here?
Yeah, let's do. I'll let you do the introductions.
All right, so I'm part of an organization inside of Juniper, the Apstra PLM team called the Product SE team. And I have a co-worker on that team who you see here, Bill Wester. And Bill has been working with us for a little more than a year, and we're so happy to have him here. So welcome, Bill.
Thank you. Thanks, everybody.
Welcome, Bill. Glad
to be here amongst network royalty like Jeff and Robert. So glad to be here to talk about some old times and new times.
Well, maybe to kick things off, is as it's kind of obvious just looking here. Robert, Bill, and myself, we all worked for Apstra back before it was Juniper Apstra, when it was just a little startup. And Jeff Tansura worked for Apstra before he jumped ship and went to some other little startup named Microsoft. And so
I wonder how they're doing. I wonder if they're going to make it.
I don't know. Yeah, they're on the edge, But way back, early in this series, Jeff and I talked a lot about EVPN, VXLAN EVPN, and we used Apstra to demonstrate some of the management of that. And so we kind of felt like, we're all Apstra here, and we wanted to kind of talk a little bit about what's going on with Apstra since that time. And we want to do it in a way that as much as we can is not salesy, but is more about intent-based networking and managing your networks with IBN systems. Yeah. Does that make sense, Robert?
It does, Jeff. And, I thought one of the things that we could do to maybe refresh people's memory or introduce the concept of intent-based networking is ask you a couple of questions, because you literally wrote the book on the topic. You wrote,
hardly that.
You wrote that guide, and so what's your elevator description of intent-based networking?
Yeah, it's a good question, and it's something I like to quote a lot. The elevator pitch is simply, with intent-based networking, you say what you want, and the intent-based networking system takes care of how to actually do that. And obviously, there are boundaries around that. There always has to be boundaries. In the case of Apstra and other vendors' products that are intent-based networking in the data center, that those boundaries are usually around how you manage EVPN networks. So within that context, you can say, here's what I want, and the system tells you how to do it. And what's really behind all that to make that work is a carefully thought out reference design that's been tested and and contains all the variables that have been verified. Does that sound right? Not authenticated. The word won't come to me. Senior moment there, but the verified reference design that that for all the vendors that are supported, when you say I want this in my EVPN network, the system takes care of deploying the right configuration, working down through the levels, from just the variables to the generic design. In Apstra's case, it's a graph relationship, and then going down and translating that graphical abstraction into deployable configurations for each specific vendor that it's deploying to.
Yes, and sorry, Bill, go ahead.
I was just going to interrupt there for a second and just go back to the point where, the complexity to create a data center in today's world that accomplishes the design goals that we all are kind of forced to conform to, right? And do that in a way that we can still, at the end of the day, converse with our other human beings and not turn completely into data center robots, I think is really leveraging. You have to leverage some type of system to do this. It's too complex, I would argue, to make something work that is so large of scale and so completely protocol-wise intense and complex to achieve the result that we're looking for. We need help as human beings. It's just overly, I think it's just too difficult. That's the way I look at it, right? I mean, there are problems that we can solve, but then there are problems that are bigger than what one brain can consume, right? And I think this is getting to that point, right? And so I think that's where, when I look at this, how would I go about building or design? I've been doing data center work for years and years and years, and it used to be easy enough. You could just, stack things and put the ports in, and it would figure, you'd use a couple of things and, some protocols and things would figure themselves out. But that's no longer the case. There's so much, I think, customization and work that needs to be done to achieve the high performance scale that we want with the capabilities. It's just too hard. That's just my opinion.
So you're describing the
right, I guess.
Mm-hmm. Yeah, so you're describing like the traditional methods for building networks. Stack things up, connect some cables, get on the command line of each device, and build the configuration. But with the modern features and capabilities in the data center, it's too difficult, as you're saying, to keep track of all of those details and sync everything up across numerous devices. So, automation is taking center stage in the industry, and why not use those capabilities to keep track of all of those intricate details and thereby eliminate a lot of the potential for human error.
Yeah. And, kind of getting down to what we want to talk about today is, I talked about you've got to have a verified reference design, to really get that. I just want to be able to deploy virtual networks. I don't want to get bogged down in the details of how it's done. And that was sort of the original mission of Apstra, and why we had a certain reference design. But then there's also a set of users that we've encountered since being in business that are saying, well, we don't really necessarily agree with your reference design, or we can't really deploy your reference design. We've built out a CRB network and your ERB, we just disagree with your choice of a BGP overlay or underlay, and we want to use ISIS instead. We're convinced that that's the greatest protocol ever. We don't necessarily want to have a traditional CLO architecture. We want to build something completely different in there. And so, Bill, maybe I'll just lean on you to saying, okay, well, we've got those kind of users that just that still want intent-based networking, but they don't necessarily want what Apstra had decided is the best way to implement your network. Right. Maybe that's not the right way to say that. It's us making the decisions for you, and not everybody wants you making the decision. Wants us making the decisions for them. And so, where do we go from there?
Yeah, so it's key that we all understand that to do what we're talking about, which was we've already portrayed this as a difficult thing. Now we've created this system, the Apstra system, which can do this, and it's automated. You can interact with it. It will impart a design that will deliver a data center network at scale with all the bells and whistles turned on, and your life is fantastic because you no longer need to design it yourself, right? It's designing it for you. You just tell it how many I got. I bought 17 of these. I bought 12 of these, and I want them connected together in this way, and I want them to build out these racks, and I've got these core switches. Great. So it builds you a data center. Like you mentioned, that's great, except for there might be some reasons that you may not be able to conform to that design, which means I already have a working network that I went through all this trouble to build. Maybe that's one reason. Maybe it's I'm like brownfield, for example. And then the next one would be possibly maybe I have gear that doesn't necessarily do the scale or the capabilities that you're looking for as an edge routing and bridged environment, right? In other words, I spent all this money on these collapse core boxes, and my edge boxes, I didn't spend that money on, so I can't use them. But I still am interested in interacting with a system like Apstra to take advantage and to help me to build out this network, because it's complex and operating it is complex. So how do I run Ansible, and do I build out this playbook? Well, that's great. I built my network now, but Ansible is not going to help me to operate the network, right? It doesn't help me if a switch were to fail, or the power supply got kicked in the data center and all of a sudden it's down. Does Ansible know that that device is gone, or that it's no longer participating in the network? And I think a lot of people are coming to the conclusion that it doesn't. And so that was really kind of the concept behind opening this up a little bit.
Well, another example, Bill, is, someone replaces a device and crosses some cables. Ansible is not going to know. But from Ansible's perspective, the configuration that it applied to those devices is intact.
Yeah, so it's kind of done, right? It's done its job, and it's like, okay, I did what I was supposed to do. I'm a program. I run my, I interact with the device and I push a config. After that point, you're reliant upon the protocols that are instilled and the failover of that protocol to take care of things, right? But can you easily identify where the problem occurred and how to kind of root cause it when everybody's yelling and screaming at you and the phone's running off the hook and you're losing money in your data center, right? That's probably not the best time to be wondering what's going on, right? So kind of think about those things when you think about how do we open the environment up a little bit. And that's really what we did with Freeform. Was we kind of set back a little bit and said, well, we're not going to be as restrictive on the topology requirements, and we're not going to be as restrictive. We're going to be more open on what you can do with it. And we're going to be so open, actually, we're going to start to expose the component pieces that we use to build this environment. And so by exposing those pieces and letting you interact with those pieces from a programmatic perspective, you can then impart any topology per se that you would like in the data center. Or if you want to call it a data center, it doesn't even have to be a data center at this point, but you can still use all the functionality of the Apstra engine, like Jeff mentioned, Graph, which is a database that allows you to basically look at connections and it's not a relational database. It's more of it's a connection oriented database. So you're looking at ins and outs, and every object in the database has parameters associated with it. I don't know if that's the best way to describe it, but that's one way to describe Graph database.
Yeah. And so is it fair to say that, that with Freeform, if you don't like our packaged reference design or can't use our packaged reference design, it's basically opening Apstra up to build your own reference design.
Mm-hmm. And you are imparted to create the building blocks on your own at that point. So in other words, we now, since we give you the control, we're going to expect you to understand how to render or create a configuration that will work on the given device that you want to interact with. In other words, so if I'm choosing XYZ switch, I need to know how to program that switch properly from beginning to end. And we're going to give you that power. Whereas the traditional Apstra system, you would never have to interact with the device on a command line level. It will render the configuration and push that configuration to the device completely automatically without you ever having to touch a command line. You can literally design a data center without understanding a single thing about a given vendor's product. And that to me is just a wonderful thing. But at the same time, if you want to figure out what's going on, sometimes you have to learn about the devices. So in this case, we're expecting you to understand the devices with engineer's level of detail. And then we're going to use tools like Jinja and the Graph database and variables like property sets and things like that to impart that configuration into the device in a programmatic way.
Bill, sorry,
go ahead, Robert.
I was just thinking as you were talking there, Bill, that I like to build Lego kits, and you buy the kits and it has the blocks that that make a perfect whatever it happens to be, spaceship, car, truck, whatever. But it sounds like with Freeform, you have the capability of custom building your individual Lego blocks, so you can build things that are beyond what that standard off the shelf kit.
Or we've given you a bin of Legos that we know you can build any type of environment or any kind of, like you said, a spaceship or a house or anything. And it's up to you to figure out how it goes together and make sure it doesn't fall apart at the end of the day. Whereas, the regular product comes with instructions, and you follow those instructions, and the output will become, what you purchased. And so the pleasure there is, the combination of parts that make something that maybe you didn't see when you first started, right? And the magic of Legos, right? So we're going to look at this today, and I'm going to hopefully get some help from Jeff and Robert to be the.
You're on your own. We're logging out at this point.
Yeah, you're going to have to turn.
I need some protagonists. So
you need to turn on your screen share there, and we need to add it.
Yeah, I was going to say, you use terms like config template and property set and all of that, and there's probably a lot of people watching going, "What the heck are those things?"
Yeah.
And so this would be a great time to actually see it.
Yeah. So can you guys see that?
Yes.
Okay.
Yeah, absolutely.
Okay. So this is the Apstra system, and this is in a lab environment that I've built this out in one of our test environments. So I will introduce the system as I expect no one to know anything, and then we'll kind of go from there, if that makes sense to everyone. So we call blueprints basically a data center design. We call it a blueprint. And in this case, since we're using Freeform, we don't necessarily make you conform to any given design. What we do is we're gonna interact with our design, and so think of it as a live interaction between the design and the human, right? And so when we're working in the blueprints tab or any of these tabs on the left, where these are more the structure of the system, and then up at the top here we've got the different tabs that you would use to interact with this design. And we start with kind of the dashboard, and we've got analytics and staged and committed, and we'll talk about all those different pieces. But the important thing is that we want to give you a quick overview of what the network is, what's going on with the network, right? So if everything is green, the network should be running as Jeff said, with the intent that it was designed with. So what we're doing is constantly validating the network against the intent that you've designed. And so if anything changes color, yellow or red, then you would see that would be either a difference or a violation of that intent, if that makes sense. So hopefully we'll and we're going to interact with the system fully, and then maybe Robert and Jeff can ask questions as we go down this road.
Bill, I wanted to mention one thing here as you're proceeding. I mean, Jeff did a great description of intent-based networking earlier, but one of the key components of IBN to me is that validation feedback loop. Continuously comparing what you have in place to what you intended to have in place, and then any variance between those two models is what generates these anomalies on that dashboard you were just showing. Right?
Yeah. And so I
actually have a question, just showing the basic topology here. Because this leads into an early demo of this feature. You've got these weird names here: Oxford Circus, Green Park, Piccadilly Circus, and all that. Oh, you are? Okay. Then
we'll explain that.
Yeah,
right.
those sound familiar.
This is good. You guys are starting to look at the picture here that we've got, and we're under the stage tab, and the staged is really where you create your intent, your design intent. So think of this as like a interactive Visio diagram or some type of network diagram where you actually kind of define the connections and the picture or the design of the network graphically, and then we can interact with it. And the hope is that the staged environment will eventually become the active environment. And so those are kind of the phases of our life cycle as you might think of the network being alive. And so as we work on the staged environment, we may make changes in the staged environment, which change the intent of the system. And as we commit those changes, the changes will be then imparted into the live network. And then the active tab kind of reflects what those changes we've made or the live running network. I hope that explains the interactions that we'll have.
Yeah.
Okay. So now you remember that we talked about how different Freeform in the perspective of it's agnostic. It doesn't care. It's not conformant to any reference design. And Jeff, when you initially created the product team that created Apstra, that had to conform to a design that which we consider, I think we as a best practice, right? Or some type of, we know this works and it's been tested and tried and true. And if you do this following design, it will deliver connectivity from edge devices across a core network, right? And
validated architectures.
It's validated, right?
Validated is the word I was struggling with earlier.
There we go. So we have this validated architecture. In terms of freeform, it's completely up to you as to how you interact with the environment and what you create. So think of these as the building blocks, and these are devices. I can change parameters and I can interact with them.
That's distinctly not a CLO architecture there.
Distinctly not, right? And what is this? This is a very small model of the London subway system. And one of our engineers, our test engineers, developed this because it was so not traditional data center. Look, it's like a hub and spoke. It's not even. It's like, you go to London, you want to get from one station to another, go from Piccadilly to Oxford Circus, for example. There's multiple ways that you can traverse that path. You could go from Piccadilly to Green Park to Bond Street and then over to Oxford, or you can go Piccadilly direct, or you can go over to Green Park and then down, right? So there's multiple different ways to get from one point of this network into the other. And the reason we chose, or I chose today to kind of demo this is because I didn't want any data center form looking environment for us to have to go, well, yeah, in a real data. No. This is not data center. This is like, we're literally just connecting things together here to demonstrate the flexibility of the system, right?
Yeah. And in fact, using BGP to schedule a subway system.
Absolutely. That's the, if you look at this, and we'll look into a little bit deeper, you can see that each device will have a link, and that link has information on it, IP addresses, point-to-point /31s, IPv4 addresses, and we're using those to create a BGP connection, and then we're using some of the parameters of the link. In other words, we're actually using meds to denote what the latency is to get from this via this link. Some subway links are shorter or longer than others, and so it takes longer time. Well, wouldn't it be better to build an environment where the routing protocol can denote what's the best path to get there? And that's basically what we're doing here.
Bill.
Yeah,
I'll say that the London Underground is a great example if you're trying to illustrate connections or relationships between objects.
Yeah, it's a lot easier for me than the Tokyo subway. Let me just say that. So,
sure.
So we're going to play with this today, and I'm going to try to interact with it, and you guys can help me to try to do that. And so we have sub tabs underneath the staged environment. One of those is the physical, and this is the topology. So this is where we define and interact with topology. And we've tried to make it as easy as possible to interact with these devices. I have a little gear button, and I can do things like setting the color. I can set the host name. I can tell what type of device and assign a system and tell whether it's in deployed or undeployed mode. So there's a lot of things I can change just right off the bat. I can even, change where the device lives on the diagram. And, for us as humans, that's important, right? Because we can set these elements into the design, and then we can understand where they are in our minds. And then so this helps us to kind of relate to what we see when we generate a rendered configuration, right? We can then look at it and go, oh yeah, that guy has 1, 2, 3, 4 active interfaces. So if I look at this device, it should say there's 4 interfaces, right? Not 5 and not 12. Even though there are more interfaces, we're only using 4 in this case. And so this interaction is something that we have imparted that you would not see in the DC reference design that we would normally use, right? In the normal design, you would have like a very strict, you've got a rack structure at the edge. There's top of rack switches, and then those racks are lined up underneath the spines and the leafs, right? And so that's what you would have in a normal. But in this case, we can make anything we want, and I can edit this, and let's say I want to create a new device. It's as easy as just taking that device and plopping it in here, inserting it, and then just naming it station new or whatever you want to call it, and we can put a host name associated with it. I'll just name it the same and assign a device profile. If there was a system, we don't have any systems available in this, we could, but we don't need to. And that's something else that we probably should talk about. One of the wonderful things about this is that we can interact with this environment without having to have real devices at any time. We can build an entire data center on a scratch piece of paper here, not paper, but virtual paper. And we can build it all out and get the rendered configuration. And we don't have to say, oh, I don't have one of those devices, so I can't build this environment. No, I'm in a staged environment. I can do anything I want here.
And just to state the blatantly obvious, when you start a freeform blueprint, you get a blank slate.
Oh, yeah,
you deploy your nodes. You specify the device profile for that node. You specify the links where you want that node connected.
I can create a link between these two devices. There's it's pretty interactive. We can create a link, create new link. And then, it knows how many links have already been used. So it's like, oh, well, you already used 2 links on Bond Street. So we're going to use the next one, which is
so
right?
Pause right here for a second. I'm looking at these ports, and you've got some ports that have already been allocated to links, on the diagram. I imagine that device profile that you selected earlier has a lot to do with the structure you're seeing on this screen here.
So we do. Yeah, we do have you kind of how can you say it? You decide what type of device, and that's done by a device profile. There is some abstraction there. So a device profile is just a way to map this logical device to model a physical device, and it's an abstraction layer. Got to have something, right? So it's a switch. It's got so many ports on the front of it, and it's 10 gig. Those type of things. So
that kind of forms your boundaries for your set of possibilities for the network that you're designing.
And we can spend a lot of time here, and I won't go crazy, but I'll show you that we also have we have a systems pane where it shows all the systems in a more, I would say, like a spreadsheet type of view, where you've got tabbed, formatted structure, and you can interact with them that way. It tells you what we're using. Juniper's a VQFS in this environment, and this freeform is new, so we can only support Juniper devices today, but in the future, the idea is that we'll be able to support multiple vendors. The framework is all in place inside the system, so there's no reason why we shouldn't be able to. And then the links, we've got, as you can see, we've got these tags that we can associate with systems and links, and those tags can be used inside of the rendered configuration to generate the configuration. And so here's our new link that we've created. And inside that new link, we've got the tags associated with the latency between the stations. And we've got some IP addresses associated with them. And you'll notice that these IP addresses are created by the system. I haven't typed an IP address anywhere along the way here. We have functionality called resource management, and that is kind of like, you would think of it like an IP address management subsystem that you can then create graph queries, and those graph queries can then generate things of objects like ASNs. We create an ASN per system in this case, or autonomous system number. We can also generate loopback IP addresses, and it will keep track of them. And as we add a new system, the systems will automatically, you can see the station new here. This guy was generated after I created that system new, and I didn't have to create this loopback IP address. It was just automatically created because we created a new element in the design. And when we created that new object, I use object, maybe overloaded in this case, but that object started a new node. It's a node of system. And so when the graph query was executed, it found a new device or new object, and created an object, this IP address, IPv4 IP address. And the same thing happened when we created the link IP addresses. We're using a node of a link, type link in this case. So the scope or the graph query is different. It's looking at links instead of systems. But what it does is it's looking at links between these two systems, and it's then allocated IP addresses for the point-to-point links between those systems, which is great, because now, Jeff, I don't have to worry about, my BGP. I know exactly what IP addresses are associated with those links, and I can use them in my Jinja to create this, and we'll talk about that next.
Well, what you just covered there, Bill, is what I would consider a perfect example of automation.
Absolutely. I have not. You're right up the alley there. I'm a lazy, network engineer, right? So I have not had to, other than defining this network pool, I've told it, that it's a 10/8. Other than that, and I've allocated it, and I've created these graph queries. Once I've done that, everything is automated. I haven't touched the system. I have not had to type a single IP address or keep track. And this is the thing that Jeff and I, as we age, my biggest problem in life is keeping track of everything that I create and where did I put it all, right? Because, Jeff, you and I can go off and create a spreadsheet, and I can create this into this spreadsheet. And that's fantastic. I've got it in the spreadsheet, and you've got access to that spreadsheet because we've got some type of online sharing of our spreadsheet. But what happens when you go in and you decide that you want to interact with this physical environment, and you say, well, I don't know what Bill was doing, but I don't think this should be here, and I'm going to make that change. And you just changed the environment. And then we went and looked, and if I look, the IP address associated with that link is no longer there. The loopback address associated with that there's no loopback, so that's gone. So
and those resources have been returned to the open pool.
Right? Yeah, absolutely. So that we can go in and reuse them. And so that concept of you and I not having to go into a spreadsheet or a Visio and update a diagram and have this automated closed loop. And remember, we're operating on a staged environment, so we're not touching our production environment. We're able to play here. We're able to allocate resources and build environments without interacting directly with the devices. So,
Bill, it's like what you just showed there is that if you were editing a Visio diagram and added an object, and it automatically went to Jeff's spreadsheet and pulled the IP addressing, and that linkage that doesn't exist in the real world exists in this system.
Yeah, and then let's take it. Let's take it further. No, it's great. I want everybody to understand that, and then we'll take this further, and we'll show you a couple things as now you say to me, great, Bill, this is all fantastic. You've got this little pretty diagram, and you can make IP addresses appear and disappear magically. fantastic. I love all that. But how does it generate an actual configuration that I need to actually get on my switch, right? Because now we've got okay, we've got this arbitrary network design. I've created links. I've got some tags associated with latency. I got all this idea. Now I want to actually interact with the environment. Well, we've kind of tried to break this down in a way that you could impart this configuration in blocks or pieces. That's the way I look at it. And we use Jinja. And Jinja is a templating language, usually used for HTML websites and things like that. So it's a very simple language. And here's an example of how simple it is. It's just it's got the squiggle and the percent and to denote that this is a Jinja. And it says include this system.jinja or the interfaces.jinja or protocols. And we break it down. I break it down because Juniper specifically is very good at making things, how do we call it? It's context sensitive in terms of the stanzas, right? So the configuration is broken down into modular pieces that we can then develop or write independently of one another. So in other words, a system Jinja file doesn't necessarily relate to the protocols, right? They're pretty independent. And so that's the way we've broken it down. That doesn't mean you have to break it down that way. It's totally arbitrary. You can do whatever you want, but that's the way we've decided. And so this main Jinja, it just basically includes these other sub interfaces, these sub Jinjas. So system is very easy. It just says, hey, put the system host name as the host name inside. This is a Jinja syntax that basically says use this imparted variable called hostname. And I can edit this config template. We call it a config template. It's just a template of configuration, right? That's why we call it a config template. And we can interact with the graph database that's built in to Apstra by pulling these things like the name host name out of this graph database. And how do we do that? Well, let me show you how that looks from the system's perspective. So now remember, we're exposing kind of the details of how the system works underneath the cover. So we're looking at the back end now. The front end is the pretty GUI, but now we've switched to kind of like exposing elements of the back end. We have this imparted 3-pane editor. We've created this editor to try to help us. This editor helps us because it can dynamically render the configuration live. We don't have to go back and forth. So you could think about that for a second. So I'm selecting the system in my topology, and then I've got my text over here. And if I preview, you can click on it and you can see that this here has rendered this over here. So it's rendered system host name, and then it's used the host name. And where did it get the bond street? We'll take a look at that by looking at the device context. And the device context is the backend. It's the graph database we are interacting with. So I'm going to go into the device context, and I'm going to show you that inside the device context for this device, there are all these things like host name, which is bond street. So these variables are exposed to the rendering Jinja, if that makes sense. And so you can then expect that I can interact with this, and I can pull information from it. And I can do lots of things. Like, for instance, Jeff is like, hey man, tell me more. You've got these interfaces. Well, how do I know what interfaces are actually used or not? And the interfaces are all listed here, and it can tell you things like the description shows who it's connected to, what is his IP address, what's the prefix length, what's the name of the interface. And so I can use that in my my interfaces Jinja. So let's go back and I'll show you that for quick second.
Is it fair to say the device context is composed of all the elements that make up the graph database? So you're basically saying this is the context within the graph.
Yes, it's the context within the graph, but it's for that specific device that we've highlighted, right?
So
because
those
the
would
graph
be
big.
the unique attributes for a given device.
The graph could be very large, and so we're keying down on one little piece of the graph that's that device's context. And so if I look at this is another set of Jinja. It's more complex. It's not as you know, it's not rocket science, but it is definitely more programmatic. And so we're setting a variable. Okay, that's not rocket science. And then we start with the interface's stanza, and then we do a for loop. And you know, we use the interface name, right? Remember that we had that device context, and inside of it, the interfaces. And if you click on an interface, the interface has an ID, it has an interface name. And so it's basically saying, find that interface name and place it there. And that's a variable and we can use. And so, you know, and then we also, if we're looking at if it has an IPv4 address, and it does, so it, in theory, should do family INET address and then look at the iFace. This is the key value for it's looking for the value of the IPv4 address, right? So pretty cool that we now see we've got this rendered out. So this is starting to build our device's configuration, and we can interact with this. We can edit this. We've tried to make it, you know, we've changed colors and made it interactive. And so we can then insert elements in this using that device context. And so just one other thing we try to help you with some functional references that we've got built in for functions that you can call. We have also property sets, which are, if you could think about it like a host vars in Ansible or some type of variable, and you see that we've created, this is just editable bunch of variables. And these are, you can see this is a little less automated, right? So this is a, you know, a dictionary basically that has, you know, the system name, and then underneath it has these key value pairs like ASN. And we've just manually set these ASN numbers and loopbacks. Well, that's great, but if I want to make a change, say I want to add a new system, I have to create a new entry in this property set, which is great, and I can refer to that in my Jinja. But what I was showing you earlier is that we have this resource management where we can look at these parameters that have been created automatically. So we no longer need to use that property set. But you could, if you wanted to use property sets. We give you the capability and the functionality to do either way. So we've got, under our catalog, we've got config templates and device property sets here. And, you know, this is just an example of that. But so you decide how much automation you want to put in to the environment. So Jeff, you and I may say, well, we're just getting started, so we're just going to use property sets to start with. And then maybe later, when we get a little smarter and we've used the system a little more, then we'll start using resource management. And we can do that. And
so you can kind of make it more sophisticated as you go if you want.
Yeah. In fact, if you want to make it as dead simple as possible, a config template can literally be a copied configuration off of a device, which is, to me, pretty powerful, right? You could literally just take, you know, I've got a switch, it's already pre-configured. I'm just going to copy the entire config and stick it into a statically assigned config template.
I was going to ask earlier when you were showing the Jinja configurations in the config templates, you know, and say, well, does that mean I have to be a Jinja expert? Not that it necessarily is hard to be a Jinja expert, but, you know, is it required?
It is hard if you go into like the more advanced these are very simple examples, but like, for instance, we're using, the for loops. And if you're not comfortable with this type of syntax and you're just starting out, nobody expects, knuckle dragging 50-year-old network engineers like me to understand this programmatic, interaction. So we have to come up to speed on this, right? It's going to take us time before we're comfortable. But we're very comfortable with like this protocol's LLDP stanza, right? Like to us, it's like, okay, God, yeah, this makes total sense to me. Or even the BGP. But when you start walking through for loops inside of your BGP, walking your neighbors, which is something that's totally possible. If you look at this, I am not, there's no static assignment of my BGP neighbors here. This is all dynamic, and it's wonderful that I don't have to do that. And I can edit it. I can look at the preview, and I can scroll down to the BGP area, and I can see under protocols BGP. I'll just move this aside so we can see. We can see that it's found the neighbors, it's found the peer autonomous system numbers, and the export policy associated with those neighbors. And I have not had to manually type this. This is all generated from this Jinja, which I think from someone that sees Ansible every day is probably like, yeah, this is easy. I can do this.
Bill, to me, Freeform reminds me a bit of what an IDE, an integrated development.
Kind of, yeah.
Well, might be for generating network topologies.
Yeah, all the way down to the color coding.
Absolutely. We tried to make it as comfortable as possible. Kind of a baby IDE built in.
Yeah, and I love how.
Go ahead, Robert.
How you're building your assemblies on the left. Your modular components of configurations, and then in this view on the right, it's putting it all together. So you're seeing the final output before it's applied to devices, right?
Yeah. And we've built a bunch of examples as well. So, there is some public Git repos out there that have a bunch of this in it. So you can take example, the easiest way to code is just to find somebody else that did it and copy their stuff, right? So that's the way I look at it.
One of the things that I wanted to mention, I mean, this is obviously, you're just looking at the rendered configuration. That's obviously a Juno syntax. And there is a question that's been lingering here for a little bit from one of the viewers. This is from Maxim. We're looking for a good place to insert it, so maybe this is it. Okay. And he's saying, well, is the system open enough so that an end user would be able to onboard a new vendor by himself, or do I need Juniper's help to do that?
Well, vendor is difficult. Vendor is big, right? So if you're going to switch from Juniper to Cisco, for example, the syntax is totally different, right? So there would be a different device context and different environment here. But in theory, when Apstra says, hey, we're going to announce Cisco support for Freeform, for example, any of the DC any of the let's go to the device profiles that you could use that are Cisco, for example, would then show up here, and then you would just render the configuration such that it's iOS centric instead of Juniper centric, and you're off to the races at that point, right?
So the answer is really, it is something that our own engineering staff has to do in terms of onboarding a new vendor. And this is such a new feature that, since we're part of Juniper, we're obviously starting with Juno syntax, but it's just a matter of a customer asking for.
It's so easy for us to test with our own stuff that it is to go out and pull all the other products out on the market. Let me just say that we made quite a bit of progress here in understanding things. But like I said, we can go down and look at these interactions of the links and who's connected, but we can also see the rendered configuration that we generate. And I just wanted everybody to understand that, the end game is we're generating this rendered configuration for this system. And this is the configuration that would be applied to the system once we committed it. and we can go to this. We went from the stage tab over to this uncommitted tab because it's got the little yellow, and it says, hey, you're making changes here. And you can see we made link changes. I've deleted an IP address or changed its IP address because I'm starting to use some of the automation instead of statically configured these IP addresses. So you can see I made some of those changes. I've added these resource generators, and it even calculates full differential in the configs if I wanted to see that. It's going to show me any build errors that showed up, like for any rendered configuration changes, any warnings. And then we can just say commit, and I can say I want to, commit first instance of resource allocation.
The power of generating those configurations and being able to review them on that granular level you were just showing.
Oh, it's so wonderful.
To devices, that's pretty doggone powerful.
Yeah, and you're now interacting. I just committed this to the network, so I can then interact with my my network, it looks exactly the same, right? Because now we went all the way full circle, right, Jeff? We went back to intent, right? Mm-hmm. Here's our intent, which is here, and we committed that intent to the network, and this is where the network is then now built out. So if I look at this device and I look at the rendered configuration, this is the actual config that's been pushed to the device, and I can see my links here all green. I see what's up and down. Anything that's violating intent would be red, and I can look at LLDP information, things like interfaces. The actual config, this is the config that's actually running on the device. We pulled that configuration because we're interacting with the device through an agent. So that agent is constantly working against that device and making sure it's conforming to what we want and it's programmed correctly per what I've sent it to do. So there's lots of, I can look at anomalies. If I wasn't as good, I didn't make any major changes, so there's not many anomalies. And we might want to have another session on day 2 operations. But the concept of day 2 here is wonderful because, Jeff, if you want to make a change, you literally can go in here and interact with the Jinja. You can interact with the catalog. You go in, change a property set. So if I want to change the loopback address, or one of these, I can just literally go in and say, oh, I didn't mean 47 here. I meant 49, right? And literally just update it. And what happens is the system sees that we've made a change, and then will create a diff, and it'll say, oh, well, you changed this property set, which is great, and it shows you, what did you change? It says, oh, you changed this 47 to a 49. Okay, mm-hmm. Great, right? I can do a show diff only, and it'll show me just what's changed. But since we changed the whole thing, it's going to think the whole thing has changed, right? But we've changed this property set. It's already calculated that there's no build errors or warnings caused by this. And when we do the commit, all we say is updated property set for new ASN. And we hit commit, and it will push that, and then the ASN would change on the system instantaneously. Basically, it would push that configuration out to the device, and that's really our day 2 workflow, right? Our day 2 workflow is we go into a stage, we modify the intent because I can't. If I look at active, I can look at the catalog and I can look at the property sets, but I can't change it. Right. Yeah. The only place I can change this information is I have to go back to the stage tab to make that change. Right. So I'm changing intent over here, and I'm looking at the result of my changes here, and I can go into Time Voyager here, which is even better, and I have a rollback. So I can say, oh, well, you know what, Jeff, I didn't like that you changed that property set. I'm going to restore back to this revision, which is before you made that change. And I literally roll back, and when it rolls back, it's going to generate another change saying, hey, your property sets change. So you're going to need to commit that. And then you can commit roll back Jeff change and just hit commit, and boom, now we've gone back to that other ASN number. So that's the day two kind of operation. Is from a network engineer's perspective, we're not, going in and, SSHing into the device and making changes and then acknowledging them here, and none of that. No. We're going to go to the staged environment. We're going to create the changes in our automation, and that will impart a change in the configuration of the device.
And that's a significant difference from DIY automation too, is that mainly what you're doing here is day zero, day one, design and build, but then you've still got the day two operational analytics and dashboard monitoring and all that.
Yeah. And we really haven't dived into the analytics dashboard, but we've got device health summary. We've got, all kinds of good things. We can look at traffic hotspots and all kinds of, I'm not really going to dive into that. We can create our own probes and anomalies and widgets.
That's easily another hour.
That's another hour, right? But the concept is that, when you and I interact with the environment, Jeff, I don't no longer have to remember that I changed the ASN number from 4749 and then update a spreadsheet and then send you an updated copy of the spreadsheet. And then you go, hey, wait, what did you change again? I don't see it on the spreadsheet. I can't tell the difference. I can just go back here and say, hey, look at the changes I made. And you can just go over to uncommitted time or time voyager, and you can say, oh, well, show me what change this is. I can look at it. And I can go back to that change, and I interact with the system completely here. So,
and that Bill truly underscores the definition of single source of truth in regards
absolutely
to technology.
Yeah, your source of truth is no longer Bill and my spreadsheet capability or my fancy network drawing tool that I just dreamed up in my sleep. Or my PowerPoint slide ability, right? I'm using this as my source of truth, which is, to me, as we all age and we can't remember where anything is, even at our desk, where did you put that, right? I mean, it's just so wonderful to have this environment to work with.
I don't recall ever seeing, live LLDP data in Ansible, and also I don't recall seeing a capability like Time Voyager where you can just immediately queue up a snapshot of the network in the past and immediately move to that deployment.
It is pretty magical. So, we can look at links and, aggregates and all kinds of stuff, but, anomalies and it's very complete, I would say, in terms of what I would ever need to do my job as a network engineer. It's pretty good. That's just my personal feeling. We, of course, will keep improving, but it's a good start.
Yeah, and we're just a little bit past the top of the hour, so it's probably a good place to wrap up here. Robert, any last thoughts on? Sorry, Bill.
Yeah, maybe we could do another session about other things in the future as we discover or come up with new, things to work or explain, and see where we go from there. But it's very powerful.
Great. Well, Bill, I would like to thank you very much for joining us today and presenting Freeform for us. And Robert, thank you so much for. We'll have to do this again. Next time Jeff T is off on vacation playing somewhere, or maybe the next time I'm off somewhere, you join Jeff.
At your service, Jeff. Thank you so much for allowing me to step around the camera to be on screen with you guys. It's quite an honor.
Thanks for having us, Jeff.
It's been great fun. And thank you to everybody that is viewing for joining us. Really appreciate your time and attention. And as always, please be sure to like us on Facebook and subscribe on YouTube. And with that, we'll sign off until next time. And I should mention, Jeff should be back for the next episode, and we will be continuing our series on switching silicon. So thanks very much.
All right. Take care, guys.